Good morning, learners. Welcome to today's science lesson. We're continuing to look at the chapter electricity. And in our previous lessons, we've been looking at the sources of current electricity, where we mentioned many of them. We said torch batteries, the car battery, generators. We talked about so many of them: dynamo, bicycle dynamo, petrol and diesel-driven generators. We have geothermal generators, wind-driven turbines, and lastly, we had the solar energy panels that we say they convert light energy into electric energy. Now, today's lesson, learner, we are going to look into simple electric circuits. And for us to be able, remember, I drawn for you what a circuit is. And we can define a circuit as a path that allows electric current to flow. So we say a circuit is a path that allows electric current to flow. So that path must have so many things that I'm going to mention in this particular lesson. So in most of the circuits, the path is made of wires. In most cases, the path is made of wires. Sometimes these wires are also called connectors. An exam, you can be told this is a connector, meaning that it can be able to allow electric current to pass from the negative side of it to the positive side of it and up to the battery or the bulb. So for electric current to flow through the circuit, a source of electricity is required. For a circuit to allow electric current to flow, a source of electricity must be present, must be there. So what exactly are we saying? That there must be a source of electricity. We can have the bulb, we can have the connectors, that is the wires, but we cannot have electricity if the source is not there. So the source in this case means we can have dry cells, we can have generators, because it's the one that is going to generate the electricity that is going to be passed through the wires and up to where we have the bulbs. Like the electricity that we have in our classes, for the bulbs to be able to light, there must be a source of that electricity, and therefore we talk about the cables that pass just near our schools that provide the electricity. So in most, a torch bulb is to show that there is electric current flow. So for us to be able to say know whether there is electric current flow, a bulb is used. A bulb is used to show whether electricity is flowing. So that if you see the bulb lighting, you know exactly there is movement of electricity from the source through the connectors to where the bulb is and up to the filament, which is going to burn and light. So when the bulb lights, the circuit is complete. When the bulb lights, then the circuit is complete. So we can talk about the circuit being complete whenever we see the bulb lighting, meaning that the electric current is able to flow from the source through the connectors to the bulb and up to the filament where we can see the light. So if we have all these things, we have the source of electricity, we have the connectors, which are the wires, we have the bulb, then we can talk about having a complete circuit. So I want us to have a demonstration of one one simple circuit, whereby we need to have the source of electricity that is going to be the cell, the dry cell. And as I told you, the cell is marked here positive and negative. Then we shall have also the bulb, and now the bulb at that end, whereby the bulb, another part here which is black, and you will be asked that in exam. Where do we have the positive and the negative in a bulb? So from there, we shall have the connectors, that is the wire, from that point, and it's going to be wrapped here. So you don't tie this wire connector here, we rather do it here on this part. This part. Then we have the filament. So we can be able, these are a simple electric circuit that you can be able to label. So we have A, we have part B, we have C, and then of course we have D, that is going to be here. So this is D. So if you can be able to label these parts, then we'll be well acquainted with what we're supposed to do. So in this case, this is where we have the filament, and this is the bulb. Number 2, where we have B, is we have the positive part. Positive. So you can be able to see from the bulb, from the negative side here, this wire goes to be wrapped on the positive part of the bulb. Then the negative part is this part here. Here we have a negative part. So this is positive part of the bulb. Then C, the positive part of the dry cell. And inside this other thing here, this one is the negative part. The negative part of the bulb. This part here. The black part is the negative part of the bulb that lies on this part of the dry cell. And of course, number D is the dry cell. Now the dry cell in this case is the source of electricity. So once this one is complete, you'll be able to see the bulb lighting. The bulb is going to light because the circuit is complete. So the observation we can be able to make from here is that the bulb lights with the correct points of contact for the bulb and the dry cell are established. When the bulb lights, we say we have a complete simple circuit. So when the bulb lights, we say we have a complete simple circuit. A complete simple circuit. Sometimes the bulb can be written like this. If you see something like this in a drawing where it demonstrates about electric flow or current flow, this means bulb. This also indicates that it's a bulb. So we agree with what we needed to do in this particular lesson. But just to mention that when you connect a negative part to a negative part, the bulb will not light. So two light paths makes the bulb not to light. So if it's a positive and a positive, the bulb is not going to light. And if it's going to light because of some reason, then it's going to be dim, depending on the amount of voltage that you're applying on here. What we mean by voltage is that you realize that a dry cell, one dry cell has a voltage of 1.5 volts. So if you have dry cells, maybe 3 of them, you multiply this by 3, and you realize that this 4.5 voltage. But now depending on the type of arrangement, this type of arrangement is called a series, a parallel type of arrangement, where a series one, where a negative is connected to a positive. But where a negative is connected to a negative and a positive to a positive, we call that parallel type of connection, whereby only one dry cell is used. So even if you have 10 dry cells, you only have 1.5, not 1.5 times 10 to give you maybe 15 voltage. It's going to be 1.5 all through. This is what I mean, Lana. If you connect dry cells in this manner, assuming you have dry cells, assuming 4 of them, you connect them in this manner. This is a positive to a positive, this is a connector, a wire, and a wire, and a wire, a negative to a negative, a wire, and a wire. If you remove this now, you bring a bulb there. This bulb is going only to use one dry cell, because this connection, where a positive is connected to a positive, we call it a parallel connection. Parallel connection. And in parallel connection, only one dry cell is going to be used. So if these are 1.5, all of them are 1.5, but only 1.5 voltage is going to be used. If you try to connect this in the other form, that is a series connection, whereby there are 4. We are assuming there are 4. This is what we call series connection, whereby, look here, this a negative connected to a positive, connect to a negative, positive, negative, positive, this positive and this negative. So if you look at this line, if you bring a bulb here, this bulb is going to use 1.5 times 4. That is going to be 6 voltage, because each battery is going to be used in this case. But this connection where a positive to a positive, this one we call it a parallel. So this is a series type of connection. So depending on the connection, then you'll be able to realize that you can later have a dim light or a very bright type of a light. So now we are through. When we meet in our next lesson, we are going to look into what we call good and bad conductors of electricity. For a blessed day, ensure that you make all these notes keenly. Ensure that you find questions of this nature concerning simple circuits and be able to attend them. God bless you.